Hello, good afternoon. Hey, Albert. Good evening for you, or good night, I guess. Um, Hopefully your day was good. Thanks for stopping by and saying hi. And apparently, good luck for me to start streaming right when you loaded the page. That's also good timing. Albert, you were there for the announcement this morning, right? All right. So in the meantime, you can see that things went like okay. It clearly we have some bugs though. I don't know why, but sometimes it kills the generations really fast, and it doesn't seem to happen early like this. It happens after many hundreds more generations. It starts killing the generations like sometimes within a few ticks, which I'm not exactly sure what that's about. Because it's not happening right now. Maybe it's just on the Windows system it was doing that. But yeah, it was training them, unfortunately, to fire as quickly as possible because sometimes the generations would end very quickly after creating them. Maybe it's a new schedule released. Or it's the announcement that today is the last day of 2023. Well, today is not the last day of 2023, but that would be an interesting announcement to make. It's like, I'm changing the calendar. Sorry, Saturday and Sunday don't exist anymore. It is now the new year. Tomorrow is the new year. No, it's that the new schedule, the exact hours haven't been released yet, but I will be doing longer streams on Monday, Wednesday, Fridays for next week. Then we'll be playing it by ear every sort of week to sort of like tweak it around again, make sure it's working the way we expect it to. Shandu, hello! How are you doing today? So yeah, the big announcement is that I'm going to 10 hours a week for my day job. And so therefore more stream time for me. So I'm planning on doing 5 to 6 hour streams Monday, Wednesday, Friday. And then the days can change. I basically want 3 stream days, 1 day of just sort of off stream day, 1 day for the day job, and then I'll have a chore day at home and then a planning day kind of off day. Let's see. TB Schneider, hello. How are you doing today? And we're going to be breaking them up. We'll have 2 of the streams are what I call value stream days. So like one is going to continue working on the Git project, the creating our own Git in Rust. And then one is going to be dedicated to building courses. So we're going to figure out what the course that we're going to build is and then start building that. And then one is going to be dedicated to fun, like a lot of like programming type fun. So I think today is going to be the last day on this specific project, but I feel that we've learned, I feel that this project has taught us all that it's specifically going to do, and another project is needed for like the next step. Like probably actually creating a game and then trying to create a bot to actually learn how to play it. That being said, there's been some other requests for we're doing ML AI stuff. Yeah, so that's what this is. This has all been ML AI stuff, specifically neural evolution type things. You want to know how I built it? How I'm teaching a bot? Yeah, so let's go over that. That's a good transition into what we've been doing. So we obviously have a very simple sort of game here, as it were. We can't play it at all. It's just the bots are the only ones that can play it. There's 100 of them that are all sort of in the same space here. Yeah, you'll be able to attend because it starts after the morning stream right now starts, and it ends like after now. So, or around now, I can't remember. Something like that. So it'll be good. Okay, so the way this works is that we have 100 of these bots, and I call them individuals. So let's load up our code. You know what would be fun? Let's get, because I still have the other one running on the desktop that's like really long. Let me see if I can pull that up, create a source for that. Okay, that's a bit big. Oh, that also doesn't have a background. Oh, that's weird. Okay, filters. Let's not color key that out. And let's put that. That way it'll go up there in the corner. That's where. I mean, I could also put it behind me. Let's see, how do I, where's me? Main camera. You go up there. That kind of works, right? All right, Albert, you got the watch streak. Well, have a great rest of your night. Have a good sleep. We'll see you in the new year. Is this annoying for people? I can move it up too. It feels weird having it behind me. I'm gonna move it up here. Zilby's not here, so I don't have to worry about it. About him until if he decides to show up, then we'll do that. Okay, so let's take a look at our code. So we start in, so we have the game itself that's running. And I have that as like the main application, as it were. And we're using GGEZ. If you're not familiar with GGEZ, it is a very basic, simple game engine, but it's perfect for things like this because it's very simple to set up, very easy to get going with. It doesn't give you too much, and it doesn't sort of like get in your way, as it were. For like really complex games, it's definitely not the right choice, but it's published and it's out there, so it's it's pretty stable and solid. It's not changing that often. So we have our game state. No, this is the wrong library. We have our entire game state here, and I have these entities. So these game entities, which are not really like perfectly created, there's probably like there's a lot better ways that I can deal with this. These are the things that we see on our screen. So our players on the left, so the circles on the left, the target on the right, and all of the bullets are all technically entities. So everything is one of these. So they all have positions. The vec2 here is basically, think of it a vector, but it only has two things, so x, y. It's created by glam, which is something that's re-exported by GGEZ. So I'm just using that. And it has all the vector math that you'd expect that a math library has. So we have our position. We have their size. Everything is just white right now. So the color, like storing the color, is like not really all that interesting. the velocity and acceleration. So this is a movement trick that you could do where you basically just say on update, just add the acceleration to the velocity, add the velocity to the position, and there you got movement. Coding Garden fan, hello. How are you doing today? It's been a while. Happy Friday. So let's see. I do have a cooldown in here, so the bots aren't allowed to. They're now allowed to shoot more than once per generation, but they have a cooldown. So the way that cooldown works is on update, I just basically reduce the cooldown by 1. And so the saturating sub here allows me to reduce this by 1, and then even though it's a U8 essentially, it can never go below 0. You're going back to JavaScript, TypeScript from Golang, and the error handling is killing you. Oh, I'm sorry about that. I mean, everything, so like learning new stuff is always, there's always those pain points. But my day has been pretty good. It's nice to sort of like end out the year with a good sort of like stream here, get everything going, and then also have a new schedule coming up in the new year, which is very exciting. Okay, so basically our update is just moving the entity around, and then also the cooldown so they can fire again. When I initiate here, I also so these players are just entities, and these players are separated from the bots. So I generate them from the bots on every generation. So basically it's like the entities get wiped out and cleared and then recreated again with each new generation, which is the reason why, as we're watching this, it all the aims sort of reset to the front because everybody starts with aiming straight in front of them. Yeah, from what I understand, this is reinforcement learning. Where I have like a score, and I'm telling them at the end of every generation, we sort them by how they did, and then we kill everybody who sucks. Cool stuff we're doing. Yeah, it is a lot of fun. It's pretty cool. So of course the most interesting thing is the population here. So when I initialize our main state, we set how many bots we're going to have. So I have 100 right now, which I have no idea what the ramifications are for this. You wrote the code to tell them how the game ended? Not exactly, because like it's not really a game per se in this one. It's really just a target that they're shooting at. So we'll get to how that works. So I go into our bot and I run new. And if we come in here, I have a sub module bot. And then when I create a new, it creates a population based upon this population size that we pass in. And then we also have some setups here. So for currently we're keeping 10% of the bots, the top 10. We are keeping the top 5, then just 5% of the rest of them. And we're also having a 25% mutation chance when they reproduce. Then and then that creates that. We create everything else. We get the target going. We apply the force to the target, so it just bounces up and down forever. And then the update tick. So every tick, the update function gets called. Now we're trying to we tried to speed things up a little bit by then adding in this FPS, and then we check the update time, and if we still have time for this, we just run another loop through this. So basically we're doing a whole bunch of what is it called, updates for the physics engine, but then we're not drawing on the same sort of speed as the updates, which are causing, that's the reason why the text here is lying. I realized that a little bit too late yesterday, that this all is kind of lies. And also why some of these I think disappear is because they're in the middle of running through when everything gets reset, because it's like half a tick, which is fun. Okay, so in update, we just grab a bunch of information about the game, and we're going to use that to pass into the bots to let them know, hey, here's what's happening. And so I call that the game info. So this is essentially what each of the bots are seeing. And I loop through each of the individuals, and I call the play function. So that the play function is where they make a guess. So I normalize all their information. So I turn everything into a number between 0 and 1, or -1 and 1, depending. So in case the position, the X and the Y become a number between -1 and 1. Rotation becomes a number between, I think, -1 and 1. Target position and velocity all become those numbers too. And I then create an array of these inputs. There's 7 of them. And then I have 2 perceptrons. And so I ask the bots to make a guess. What do you want to do? Here's your inputs. What do you want to do? And it's going to give us back a number, either 1, -1, or 0. That's it. That's all each perceptron can do. And we have 2 perceptrons, one for rotate, one for firing. And the way the guess works is super simple. I have a bunch of, each perceptron is basically just a bunch of weights. And so I take each weight, and each weight is multiplied by each input. So the weights have to be equal to the number of inputs that we have. Does this Rust code use multi-threading and stuff like that? No, it does not. So this game engine is a single-threaded game engine. You can do some multi-threading behind the scenes, but I don't think it would be really helpful in this case, because I'm not doing it's like a one-to-one for reinforcement learning. If I were to somehow try to do extra learning on top of the reinforcement learning, maybe that could be done in another thread. Okay, so that's the guess. I run it through this thing called an activation function, and all that's really doing is just figuring out, okay, here's how I know what is a 1, what is a -1, and what is a 0. That's it. And then I return those in an array. So we have a rotation guess and our fire guess. Those are commands, and so then I just take those commands and I just play them. So because it's the two different, because first it decides if it's going to rotate and second decides if it's going to fire. It can both be rotating. It can be basically aiming and firing at the same time. So think of this like it has two hands. One hand is working on aiming and one hand is working on firing, and that's it. That's all it can really do. We create the bullets, we do all that stuff, we set a cooldown for the player, then we go on that. Now, I think this is where I have a bug here, where I just say like, okay, I want to end the generation now after like a certain ticks. If you fired a bullet, I think that ends up causing problems. So I'm I'm not really sure the best way to solve that with the code system that I have right now. I think when we do another game later, we're probably not going to we did this to try to make it train faster, and I don't think that that's a good idea. Okay, so then we run the bullets through. Okay, so as the bullets, and here's where you're getting to Shandu with like how they learn. So for each bullet, I get the individual and a bullet together, and I pass in, get the same game information, but this time I now have the bullet position, and it's specifically their bullet, I believe. Although in this case, it might be weird. I think like I broke it that way too. Previously it was, they only had one bullet they fire. I think I added in they can fire multiple bullets, and I didn't update the training code for that. So they might be learning on each, like other people's bullets and think that they're doing really good, which is not great for reinforcement learning. So that's another bug that I just realized right now. So I basically take this game info and I run the update function and pass in the game info. This does the reinforcement part. So it creates a score. And the score is simply how close is the bullet to the target. If the bullet is closer, like if the bullet hits the target, it becomes a 1.0. And if the bullet is, if they don't fire at all, that's a 0. So even if they fire away from the target, that's going to be more points than if they don't fire at all. So they're encouraged to fire shots. And then here, I want score. Okay, yeah, then we just set the score, and then I make sure their score can never go down. Basically, if their bullet like barely misses the target but then keeps on going afterwards, obviously their score goes down each tick. So I want to take the highest score that that bullet has ever seen, and that's what I do here. Okay, then if we've now ended the generation, so like at a certain point in time, we basically say, okay, bots, you've had all your time, we're done. Maybe if the agents are like 1K objects on the screen, they might learn faster. I think that looks like you have around 10 agents. We have 100 agents. We have 100 agents. Jim, hello. You're streaking on the stream, fully clothed, of course. Well, thank you for the fully clothed part. But nice. 3 streams. Yeah, and we can see that we have 100 agents here because the bot population size is 100. Their neural network is super basic. It's not a deep neural network, not a deep learning neural network. It's just a learning neural network. So it's one layer. That's like something that we could potentially do to like make it a little bit faster. But okay, so in here I clear out all the bullets. That's why sometimes they just disappear. It's like, okay, you had your shot, you're done. I then tell the bot to run. So telling the bot to run is really saying, okay, like entire machine learning bot, time to have another generation, run through another generation. So it clones our population, it creates a brand new generation. And when in the way that it creates a generation is we select a number of them in order to choose. We can use deep learning for this. Yeah, so my understanding, now I could be wrong, but my understanding of deep learning is just that you can have multiple groups of weights, right? So we can have the inputs get multiplied by weights. And then, but instead of just straight up using the outputs as the outputs, we could have the outputs of the first inputs to weights be the inputs for another group of weights. And then again and again and again. And a common way of sort of thinking about this Do I have anything on? I don't think I have anything. Let's just create a new one. A common way that we can think about this, we could have we have like, you know, our position, like our X position, our Y position. So let's say we only were paying attention to X and Y, just because I can just do this. So 1, 2, 3, 4, 5, 6, 7. So these are all inputs, let's say. We are multiplying those by weights. And a weight is a number between -1 and 1. This is where it gets interesting. Is this gonna be curved? So that's gonna hit into there. Can I make you not curved? Straight line. Yeah, there we go. So obviously this is going to get a little bit crazy if I try to do it for all of them, but like this X gets multiplied by every weight. And so on, all the way down. And then each of these will be multiplied by all the weights, and then each of these. And so that's how I can learn from this. So from what I understand, if I want to do deep learning, I could add in another group of weights here, and then another one, and another one, and another one. And some of the most popular machine learning algorithms are basically have a lot of depth to it. And these don't, here's where it gets interesting. These ones, we don't necessarily need the number, like, you know, this number of weights to like be that, because this turns into like the output of this is just one output, right? Normally, at least in my code it is, but we can turn this into any number of outputs that we want. So we can actually have this be more of these. And there's an actual science to like choosing what makes sense for this. So I could do something like this. Now, the problem is that you need to do linear algebra for every single input, right? So like this X, this one right here needs to be multiplied by all of these. And then this one needs to be multiplied by all of these, and so on and so forth. So you can imagine when we start having a lot of these, you know, that happens, then these create an output, which then needs to be multiplied by all of these. It can get pretty intensive CPU wise, which is one of the reasons why a lot of people end up using the GPU, because these are all just numbers being multiplied, and they're really small numbers. They're usually a number between -1 and 1. So GPUs are perfect for this. That being said, for my poor MacBook Pro, at some point in time, we're not going to be able to keep 60 frames per second and do all of this stuff for every single entity, every frame. So that's the problem. So we are currently just with this, and then this comes out to be a single output. So we have inputs, one output through all these. Okay. Now the learning here is the we keep the score, so we get the score when we learn, and the score basically just says, okay, if we have 100 bots, so let's say we have 4 bots. So for each of these bots, I give them a score. Well, okay, let's say that your score is, 0.9 because you got really close to the target. And your score is maybe 0.0 because you didn't even fire your bullet. And your score is like 0.1 because you fired like pretty much far away from it. And your score is maybe 0.5 because you went like perpendicular down to it. So it was like, no, you didn't really get that close to it, but at least closer to this. What we do when the new generation comes and it's time to reproduce and do all like the true learning part, we say, okay, we're going to take, now in mine, I take the top 10%. There's 4 here. So you can imagine like, well, okay, we're going to take the top 1 and congratulations, you survive. You move on to the next generation. And then, okay, choose 1 at random from here. So maybe this bot gets really lucky and it wins the lottery. So this bot survives too. These 2 bots, goodbye. You go and they just die. They get released from memory into the they don't even get a garbage collector to work with them. They're just immediately dead. But we need 4 bots, right? For this, so we're going to now have these 2, the remaining bots, reproduce with each other. So we're going to choose, okay, we want a bot from, give me a bot at random. So this bot and this bot, we don't have a very large generation, so they're gonna be always choosing each other, and go ahead and reproduce with each other to create a child. And so what that really means in my code here is I do this new from parents. New from parents is I'm telling each perceptron to get new from parents. I'm basically taking for the weights and like combining the weights from each parent. So it's like, okay, imagine that the weights are like the genes of each parent. It's like, okay, you get half of the weights from one parent and the other half from the other parent. So that way they sort of like hopefully get a little bit better. It's not an exact thing. It's not like actually guaranteed to be better, but it's chances are that like over time it should get better. That's the idea. Especially since we're guaranteed keeping the best ones around. So if you survive, then you move on to the next generation. So you always survive. So we should never regress too far backwards, because we should always have at least one that's just doing really good. Unless we screw up, which I may or may not have done. And then we have that mutation chance. So when we create new from parents, there is in this case, 25% chance of them mutating. What that means is that there's if they get selected for the 25% chance of being mutated on birth, there's a 50% chance that either that's going to be the rotation or the fire perceptron that is the one that's mutated. And then if that one is mutated, it chooses one of the weights and then just completely it completely randomizes that one. So rotate perceptron, mutate. Yeah, so it just generates a brand new weight for that specific perceptron. So that might be something like saying, hey, your weight, congratulations, you've been mutated. You're now something completely random, and let's see if that's any better. And if it is, you're going to end up having a higher score, or as like the more technical term is, a higher fitness, than your peers, and therefore you might rise up and be the one on top this generation. That's the hope, at least. That's the thought. And then so that's generation, and that's how they learn. So that's how that all works. And then we just move through, and like then it's just time to try another generation. We generate the bots again. We let them run through for a few frames, and then we start the entire process over again. And that's what this looks like here. So thoughts? Like there's probably a lot. That was really fast. I'd be happy to answer any other questions, or like we can look into other things. Hello, World Dev. Hello. How are you doing today? That was super helpful. Awesome. I'm glad that's helpful. Part of, like, for me, it's like explaining that type of stuff makes it really reinforces my own learning, if that makes sense. So we store all of the games of each gen. Not really. What's happening is that each player, each of the bots in each gen is a entity, and I just have them sitting on top of each other, so you can't actually see them being different, but you can see all the different aims right here. I could like do something where I only show the top one of the previous generation and like watch it go. And we're storing all the bullets, so like the game thinks that 100 people are playing it all at the same time, if that makes sense. So if I were to try to make something like asteroids with this model, it would not work. Like I would need to store. If you were a bot, you would get annoyed with the speed of the ball. The target, because like it's too slow, or because the bullet or the target? I'm curious. Because it seems they can either shoot straight or under. No, they can rotate. So all of these are their aims. So they can rotate fully to behind them and fire. So they can rotate a full 180 degrees in each direction, and then pull the trigger at any point in time. So there is the one above me, you might be able to see that they're sometimes firing like down or backwards. So they definitely can shoot more. I think what's happened is this one is pretty early on in its lifespan. The one above me is like fairly old. It takes them a while to realize that they don't have to fire their bullets all at once. So let's see, other things. I could probably actually I don't know if there's anything else to really talk about this specifically. I remember now. It was if I was to make something like Asteroids, which is like probably one of the games that I would like to try to make with this. Obviously, I don't want one bot to influence the game of another bot, because then it will have a different fitness score. So I would probably a lot more like, they're born to be wild. Yeah, fire all your guns at once and explode into space. That's kind of what they learn, right? Like they just learn that they survive a lot longer if they just fire as quickly as possible and just ignore the target. Like some of them, usually not enough of them fire the bullets to even like have to worry about this. And also like this number, unfortunately, is I don't know how much of a lie this is. That might be like the same bot firing multiple times. So let's see. All the numbers I showed you, all of them will change everything. So there's a lot of ramifications where I'm sure that there's researchers out there who can tell you what the ramifications would be. For us, I think it would be change it and try and see what happens. The only negative is that you get such a slow feedback cycle. It takes a long time for them to learn how to play the game. And that could be days, potentially, of waiting for it to do its thing. So let's see. If I were to make asteroids, okay, that was the other thing I was talking about. If I were to make asteroids, I would need to make it so that the game engine can be played by multiple players at the same time without influencing each other. So that means new asteroids sitting on top of each other, new bots that sort of like move around and do its thing. I can't just like make one set of asteroids. They would have to all have the same asteroids, right? And either I can do that by making like this maybe full screen and then saying, okay, here's like maybe we'll have 10 bots that play, and then like you get a little box, you get a little box, you get a little box, and like they all get like little boxes next to each other, or you sit them like this overlaid on top of each other, which makes it really, really, really hard to see what's going on. So fun things to look into and potentially deal with. What I didn't do for this one is create a system to record the weights down, because really in the end, all of this is doing is just setting like what the weights are. Like that's what the machine learning really is just configuring and setting up what the best weights to hit the target is, given those inputs. And if you have the weights set up right, maybe you like hit a button and it saves them to disk, and then you can go to somebody else's computer. If you load up those exact same weights, then there's still random number generation happening here, so it will not be 100% the same, but it should act very similar to what you saw. And that is how a lot of AI works, is like they train, figure out the weights, and then what you're using is not something that learns anymore. It's really just something that's using that weights, and it just makes a guess, and it doesn't learn based upon that guess. Yeah, already like here we're 793 in. We're starting to see the thing where that somehow like it's killing itself early. But you can see like they try to move up and down a little bit. Lucas, hello. How are you doing today? I don't have an OS command. Is that for operating system? Like what operating system I'm using? This is a MacBook Pro. So the Mac operating system. I think it's the latest one, whatever that is. Sonoma or something? So let's see. Not the M3. It's not the new one. It's the 2021 one. So it's the 16 gigabyte M1 Max or Pro, or what they had like the M1 Max and the M1 Pro for that, and I can't remember which one I got. But one of those, and then 64 gigabytes of memory. Which is another reason of why I can do this type of stuff. I should be able to get my, oh, no, that's not what I want. Where is my activity monitor? Should be able to get memory. here's my, okay, so this is my CPU usage. So you can see CPU usage is not too bad. Do we have one from memory? This GPU history, I don't think really gives me much. So, oh, I guess we gotta wait and let it do its things. Oh, it doesn't have a little window that I can do for memory. My memory pressure right now, I've used, my memory pressure is very low. My memory used is 33.8 gigabytes or so out of my 64. So it's very, like, I have around half of my memory left. But the way that Apple works is that it have, like, technically I have more than half left because it does a lot of caching and a lot of other fun little things behind the scenes to make sure that you don't run out of memory. So it's basically it uses like virtual memory for things that it knows that it doesn't really need quickly. So this is what we got. Now, most of this, all these calculations are happening on CPU, not on GPU. I think like actually just displaying like text out, like every frame I'm redisplaying this text out. I'm redrawing all these things. That's not like very efficient use of my GPU. And I'm also running this on dev mode, which is apparently like 10 times worse performance wise, maybe worse than that, than release mode. The one that I have above on Windows, that's the Windows system that I have that's run right above me. That is running in release mode. And it's significantly faster. It, however, does run the fans on my Windows system. And it's been running like 24 hours now. So I think I'm going to let it take a break. Some things that I think would be really fun is to figure out games that we can do where we can make where you all can like come up with weight guesses or like train your own bots or something, figure out the weights, and then upload them into my bot while I'm playing to either help me or hurt me. So like you probably would need to write some code yourself, which is a cool challenge. Like, you know, that part of it is education, right? So that would be a thing to do. But then you can like upload weights to like run a module for me to either help me, hurt me, or just, who knows, maybe it just does nothing at all. Or it just does something okay. This would make a nice base for asteroids. Oh yeah. So like if this was like in the center and then asteroids were all around it, that would be interesting. Now, what I've never done, I give it, okay, so we've never tested. I wanna redo this a little bit. I want to make it so it only fires one again. Okay, so now you should only fire let's I also want to slow it down and like not do this entire thing because I think this is causing weirdness. So let's just do that. Sure. Okay, so you. Now I'm really curious if, okay, so if we put our players into the center. So our bot, okay, so there's our target. I could put our target into a random position, but I think it's okay to put it in there. Or let both weights battle each other. That could be interesting too, to let all the bots fight against each other into like an arena of death, and then that's how they learn, and that's how they get score, is like whether or not they killed each other. That would certainly be an interesting way of doing it. Game of life against the bots. Yeah, I've seen some things about that like done by some developers where you're like, okay, we have like, you know, you're a lion, you're something else, you're whatever, and then you're going in and fighting against each other, and like the number of ticks that you survive, or I was actually looking, like I've been watching other people play Lethal Company recently, and that reminds me that could be like something for that too. Is like, okay, your job is to go out into the world filled with other monsters. It's an extraction game essentially for bots, right? Go out, grab stuff, and then make it back. If you make it back, you end up with like, you get a really high score. Otherwise you die. Rock, paper, scissors playing bots. Yeah, that, I don't know if that would be fun to visualize though. Like going out and then killing each other would be more fun. Like, okay, maybe like, for example, they have to go out and they can't, they have to find a bullet to fire it. But if they turn in the bullet, then they get money, and like the money, whatever they bring back, the value of that is what like their score is. And so like they have to make the decision, fire the bullet somebody else or make it back, because if you make it back, you get like, you know, 10% of points or something. I don't, there's so many interesting ways we could like play with bots, which is one of the reasons I'm really excited about having more time to sort of like have downtime, because it will give my brain a chance to like come up with some of those ideas, which will be fun. Okay, so if I want to create a bot, let's put you in the center of the screen. So our bot, our players. Okay, so here we have, you're already center height wise. Let's put you all. Yeah, let's also reduce our population down. Let's go with 10 population again. Let's put you in our width divided by 2 minus 50. Okay, so now if I were to run this, would you maybe have to reset the entire environment after each generation? I mean, like letting the circle on the right start again from the middle, ensure that they can fire more than once. Yeah, for like a lot of those type of things, I probably would have to do something like that. This isn't really ending the generation, is it? I need a way to mark that the generation ends, don't I? I think I broke that code. It just sits here forever now. Either I wait for them all to fire, or we go for like 1,000 ticks, as it were. So let's see. End generation. Let's wait for 500, and it'll be every 500. Then we can ask the bullets if you're still alive. So we're looping through all the bullets. We're getting the game information. We ask the player, okay, we update the individual. We update the bullet. We marked if we've hit the target or not. That's fine. I think what we really want to do is we will then also want to, probably during bullet update, in here I want to check to see if we're off the screen or not. So I need the arena width, okay, so if you're less than, if your right hand side, so plus, okay, so if you're, these are all entities too. I probably don't want to do this here. I want to do this here. Okay, so if the right hand side of the bullet, let's do left, up, right, down, right? So if the right hand side of the bullet, so if the bullet position dot x, the right hand side, that's plus bullet dot size, which is a radius. Okay, so if the right hand side is less than 0, or it's above, so bullet dot position dot y plus, that's less than 0.0, or right hand side okay, so if you're outside of the arena, we're just going to say bullet dot is alive. We mark you as you're no longer alive. You're dead now. Which means that we only have to do an update on the bullet if it's alive. And then what we can actually do is we can just loop through and count the number of bullets that are alive at the end of all this, and instead of okay, so if so alive bullets, okay, so we get the number of alive bullets. So if alive bullets is equal to 0, Or I also, how do I want to do this? Because if I just set this, like, if a life bolts is equal to 0, it's never going to let them even have a chance to fire, right? I really want them to, we need to wait for a certain number of ticks and a certain number of frames before we basically say, I mean, we can basically say like, okay, we need to have like at least one bullet. Let's try this. So if bullets, so if self.bullets dot length is greater than 0, and none of them are alive, then we go ahead and mark this as done. So basically, as soon as one of the bots fires, it's over. I don't know if this is a good idea or not. So I don't know. We'll this will kill them after 1, won't it? Let's try it. Let's see what happens. We're still in the first generation. Do you run multiple generations now? Yes. Basically, the entities that learn how to fire on the first frame live. Everybody else dies. Most of them have learned that they need to fire. So that's a thing. Also, I didn't make them over here, did I? That's or maybe they started over here, but they're no longer over there. Oh, when I create them, I need to do this again. Okay, that generation, they didn't fire any, none of them fired bullets on the second generation. Well, that's, I was gonna say like, okay, come on, what's the chance that none of them would ever fire a bullet, right? Like they've always fired bullets. Let's try again. Oh, I must have broken it. Because they're not firing at all now. And okay, yeah, the very first frame they fired 5 bullets. And then it went to the second generation and that's it. They were done. So let's see. What did I do? Oh, when we hit to U. Okay, the bullets clear out. The players, okay, we cleared the players out, so the players all have fired false again. So that should be fine. Are we hitting you? No, we hit this once, and that's it. We never hit this again. Okay. That's what's going on. Fibrat, hello. How are you doing today? Okay, so I want the alive bullets. Oh, wait. Did I do this wrong? Oh, maybe no, I'm not trying to do it wrong. How many live bullets do we have? Okay, we're down to 2. We're down to 0 now. So we have 0 live bullets, so that's it. So okay. If our bullet's length is greater than 0, so what's that? Oh, and now it's working. Okay, so it was literally just the random weights chance was low. So I need to be able to handle the case where they decide not to fire. So right now we're killing them as soon as like they decide to fire as soon as possible because that's the only way they get a score. And then they as soon as the bullets go off the screen, we'd kill everybody and they go off. So that seems to be a bad way of doing it. We want to give them like a chance to last longer. So what if we do this instead? We just give them all 250. Right now it's 500 ticks. So what if I give them all 5? We give them 500 ticks. So every 500 ticks, it's a new generation. We could just do that. I think we can tweak that. So that's going to be this here. So if ticks modulus self dot end generation after ticks is equal to 0, then clear out and start over again. That might be too long. Let's find out. I could also wait if it could be if we wait for the 500 ticks, or we also wait until if they've all fired their bullets, then we probably we're good to go with that. So if we have our alive bullets, so have they all fired? Is if we have self. Oh, I can get that from, I can get the population size from bot. Okay. Okay, so if self.population size is equal to the self dot bullets, okay, so self dot population size equals self dot bullets dot length and alive bullets, I guess, like, and alive bullets is equal to 0. So all fired, I guess, like, done early really is what this is. Okay, we're finished early if our population size is equal to self dot bullets that should be a pretty easy comparison to do. Okay, so is this correct? If our population size is the same as the bullet's length, so that would be 10, so they've all fired, and there are no alive bullets, time for us to end early. So if we're done early, or it's time to end after the ticks, then we go from that. Blitz Hetz, hello, how are you doing today? What kind of config would you like? I don't have a command for that. I guess, like, which config are you interested in? Oh, this is one of those ones where they've not learned to fire their bullet at all. That's cool. Oh, Helix and Terminal. Okay, excellent. So for Helix, I have a config at Helix. And for Alacrity, I have a config there. Note that Alacrity just updated and they now have a different format, and I haven't updated mine yet. So it's the old style. So the Alacrity probably won't help as much as it might have, like, last week. Okay, so you've not learned to fire at all. That's cool. I wonder if they eventually will learn to fire. Let's also update you. I want to go back to what was, like, initially given to us, which was 30% and 20%. And like a 25% chip mutation chance probably is fine. Okay, back to you. I think this is good. Oh, if you want to update, oh, you just type Alacrity migrate. I didn't realize that was a command. I haven't like gotten the new Alacrity yet, so I haven't like looked into it at all. But that'll be cool. Well, I'll have to take a look at it. Okay, so we have that. Let's try you again and see if this makes anything more interesting. You all fired. Okay, so they have a propensity to fire now. Okay, and then the next thing we're going to do is I wanted to just give move the target around randomly and have the target bounce off of the walls. So I do have somewhere in here, yeah, so if target position Y plus this, okay, so this is bounce Y, and then I also want to do a self dot actually just do this. Self dot target position Okay, so if self.target position X is greater than height, that becomes width. That becomes width. I want to bounce X. You don't exist. Okay, so that will bounce. Okay, that should cause it to start bouncing around a little bit more. And then I want to, on every update, didn't want to go all the way down there. I'm gonna go, okay, go to update, go to that. That's a lot better. Okay, so we update you, and then I also want to maybe right before the update, we're gonna just create a little bit of randomization and do some fun stuff here. So just so I don't have to recreate RNG over and over and over again, let's just store that here. What is it? Isn't it thread range? Oh, do I not have RNG in this thing? I don't have RNG in you. Oh, okay, that would explain why. There we go. That's what I wanted. Let's see. I heard something. Alpha Kex, hello. Thank you for the raid. Welcome, welcome, welcome. How's your stream today? What are you working on? It was good. You're working on an Axum API. Nice. Have you updated to the new version of Axum? I heard it came out today. Although I don't think very much changed with it. Another new version? Yeah, they added in graceful shutdown. That's the big thing that I've been seeing a lot of people talk about, but I don't know about any other features. Yeah, it is pretty huge, especially if you want to like do anything real with it with databases. Ah, man, it's big, but that's awesome. Is it like a production app that you're building and like deploying out, or is it like a learning app or teaching, or like any of those things are pretty good. Not really production, but it's for a small gaming community. Well, I mean, it's going to be reused by real people. That to me, that's like production. Not all productions have to be huge, right? So that's awesome. That's really cool. Let's see. So we're working on here. We're learning how to create a neural evolution bot that can play, like they can play and learn a game. And so we built a we're sort of like showing off like what our graphics card, like the pressure on that is, the CPU pressure. Up above me here, I have one that like I trained and ran yesterday. That's on a Windows system overlaid on top of me. And then also this one right here is one we're playing around with. So like I moved us ever into the middle. We have 10 bots in this one. And we're sort of like, I'm now about to move so the target starts moving around and bouncing around too. So that's what we're doing here. It's all in Rust. We're using GGEZ as the engine, and it's a lot of fun. It's a little bit to wrap our heads around to begin with, but then it's good sort of like once we get there. Okay, so I get a random force here, and then what I want to do is I want to add this to our target. So I want to say self.target apply force, and we hand it this random force. So if I do that, let's go ahead and try this. Our target is a little bit fast. That's gonna be hard for them to aim and shoot because you can see how fast they can. The bots are able to like move their aiming around. That's a bit. That's a bit much. Maybe not fair. I probably should cap their speed too. Of the target. Okay, so let's change this. Let's do search for 1.0. I want to make you like 0.1. Okay, so negative 0.1 to 0.1. Maybe that will be a little bit nicer. It's still hilarious that it's doing that. Okay, a little bit better looking. So each generation, it waits until everybody has fired or 500 frames have passed. If 500 frames have passed, then it goes ahead and quits and kills everything. I do foresee this becoming infinitely fast, though. If it keeps on trying to go the same directions, it will just continuously add speed to it. It can try to go the opposite direction, target-wise, and then that would make it... what do I want to say? I want to say it would slow it down if it tries to like reverse itself. I don't... It's kind of working. I think I've confused the bots. They stopped firing. The other thing that I could do is I could add collision detection between the bots and kill the bots in the case that they collide with the thing and then make them move around. But that might be like when we actually, like if we actually implement a full game like Asteroids or something like that, then we'd have to implement that in. I want to say that 10 is not enough. I think we should have way more bots. Let's increase our population size to 50 maybe. Okay. It still really isn't hitting my memory very hard. And it's not really hitting the CPU any harder than it was before. This would be a really interesting thing to sort of like check to see how it learns though. Maybe if it gets better or worse. I think the last thing for this that would be really interesting, because I know some of you have downloaded this code set yourself and you're sort of playing around with it. I want to add the ability to write out the weights to a file, because then we don't have necessarily a way to like restore that, but we could add them in, like even if we copy and paste them. There's only 7 weights, so it's not going to be that bad. So what I probably want to do is something like I probably want to change it. So instead of like this speed, like the spacebar trying to increase the speed, let's have like the spacebar write out the weights. So, how do I want to do this? I probably want like a function to write out the weights. I could write it to disk. I could also, let's try writing to disk. So this can be a, I need to remember how to like write a file out. I wonder if I don't think I want to use GGEZ's system for that. I might want to do something like actually creating, okay, so we want to open a file and then I want to do write. Can I use the write macro for this? Maybe. I think I want to open up a file. So let mute, so like weights file. Okay, let's create, opens a file in write only mode. This function will create a file if it does not exist and will truncate it if it does. Is there like a, oh, right, there's an option. Open or create a file with specific options if open or create are not appropriate. Also, we can check to see if the file exists. Okay, so if I do options, opens a file, add a path with the options specified by self. Not found. The specified file does not exist in either create or create new is set. Okay. Oh, so I just want to create, set the option to create a new file, failing if it already exists. That's what I want. So create new, true. Let's open a file. Do I have to say like it's gonna be a write file? Sets the option for write access. So write access true. Open a file, a path. Let's say that the path is gonna be just I want to call this maybe weights. Now, do I want to unwrap this or not? I might. If this fails, I don't know if I want to. I might want to just handle that. Okay, otherwise we'll just debug out that error. Actually, let's ePrint line. Not in interactive mode. Okay, ePrint line error opening stop. Weights.txt file. Okay. And then I want to, we'll just do an early return. Okay, so if let okay, we now have the weights file. I guess like I can just do let okay. And then this just becomes an else like that. Okay. All right, so we now have the weights file. I want to write out, so we need the weights, and then I just want to write this out to it. How do I want to do? I guess we need the weights. I need the weights for all of the, okay, let's just try printing out all of the individuals. So if I do individuals self dot oh, so I need, okay. Okay, so weights, we're gonna make that self dot bot population. That's our population. I want to probably get all the weights from these. You think you'd go crazy with all those white space? Yeah, it took a little bit while for me to get used to, but I was like running into problems where the white space was like causing me issues, and then now I'm really used to it and I like it. So like I think I just got used to it. So like to me, they sort of disappear and fade into the background. Okay, so weight self bot population. Oh, okay, so let's get an iter. Let's map. Have an individual. And I want to turn the individual oh, we get the perceptrons. Okay, so I could print these out. That might make sense. Let's just print those out. So then I probably just I don't want to do this at all. I don't need so weights is going to be format self dot bot population. If I do that, that gives us a string. I can now call the write weights to disk. We're going to hand it the weights, which is going to be a string. Okay, so we don't need to do this anymore. Now I just need to use this file. So we're just going to do weights file. Okay, so we have write all, attempts to write an entire buffer to this writer. Okay, so let's write all the weights as bytes. And then you can be a result. So we'll just do a if let error. So this is gonna be error error writing weights to file. Okay, so that should work. See how you're doing. They're mostly still, well, some of them are trying to fire at other directions. I think that they're still learning to fire mostly to the right. That felt like it hit pretty well. Okay, so if I run this, now I want to hit spacebar. I don't have anything that says that it was successful. Oh no. Okay. So that's fun. If I try it again, oh, error opening weights. Okay, so because it already exists, that's why. So if we take a look at our weights, this is these are the weights. So here's all of the individuals, so we can see what their score is at that moment, and you can see all of their. You can see all of the weights. There's 100 of them, so this is a lot. But theoretically, you could like clean this up, extract the weights out, and then hard code those weights in, or write some code to like then pull them back out again. So this could be like the beginning of like figuring out how to store the weights once you get like a really good series then. So that works. Let's add in, if we get to this point, I have an else. Weights written to weights.txt. Okay. So if I remove weights, no, remove weights, and I hit space again, it would help if I reloaded that so the code change would be there, because I don't have that set up and running. So that won't work. But this is interesting. Okay. So I know we have a bunch of other sort of experiments that we could do with this. I don't necessarily know if those experiments are good in this app. I think the next thing to do would be to build another, like an actual real game for the bots to play. Maybe even a game that we could try to play too. Like it's meant for all of us. So that being said, what do we want to do next? So my plan is okay, so I guess like first off, if you weren't here this morning, the announcement that I've been sort of hinting at that's coming, my day job situation has changed once again. So I previously was at 25 hours per week with my day job, and so therefore, you know, technically more than half time with them than here. But now I'm shifting down again, and so now it's going to be 10 hours a week with my day job, which is great. That means that I get to spend more time with all of you. So what I'm going to be doing is spending my day job time, which is no longer going to be the day job, on Friday. So I'm just going to get all 10 hours a week done on Fridays. Part of my contract, though, is that I'm available for emergencies during the day in case something happens. So if that happens during a stream earlier in the week, it's going to become a co-working stream as I jump into and do that, because they do take precedence as long as I haven't gone over the 10 hours for that week. I don't expect that to happen very often, but it's very possible that it could happen. And if it's something that's going to take like a really long time to fix, I might just have to end the stream and then go from there. Let's see. Then after that, so because I have like most of the week free and available now, I'm going to do 3 days of streams. So they're going to be, I'm starting with 6-hour streams, and we're going to just sort of see how that goes and then go from there. So I'm planning on Monday, Tuesday, Wednesday streams, with Monday and Tuesday being our value streams. That's going to be where I'm working on things that basically are more educational, more like, teaching wise, more things like that. So we're going to finish up the Git project where we're creating our own Git with Rust. That's the partnership with Codecrafters one. And Tuesday, I'm planning on having that pretty much always be a course creation day. So we're going to get back into that. And then Wednesday, I'm going to keep as the fun stream. So I think for them, I'm going to focus on mostly going for programming type games. I think I want to try the new fall coding game that came out recently. And then after that, there was a suggestion that we take a look at Leak Wars. So we might try like coding game for like one day, and then just like we'll be playing it by ear. I don't really have like a strong like need to get through things, but I don't want to spend too much time with any one game unless there's like a specific end to it. And then once we go through a few of those, we're going to come back and probably like this time would be for things like this, like building cool stuff like this, because it's a lot of fun. Creative coding is also part of the Wednesday stream. So that's the plan. That's what we'll be working on. And I know it's only 4:13, but I don't necessarily know if there's anything more I want to add to this right now. I think that we fixed the bugs with it, so it now like works. It's slower, but we give them more time to fire. The target moves around and they're in the center, so it sort of is like they're a turret. They can only move in 180 degrees in each direction. So you can see that if they choose to move up like that, this is as far as they can go. They'd have to go all the way back around to move this direction. So that's that was a design decision. It's certainly possible for us to go for like, full pi squared instead of just pi around. And then I think, or maybe it was 2 pi. I don't remember what it is. But anyways, this I think we're good here. So do any of you have any thoughts, questions, feelings? Otherwise, I'll probably go ahead and end early. All right. Well, then, with that case, I'm gonna go ahead and head out of here. Go grab dinner with my wife, and hopefully we'll all have good New Year's weekends, and we'll come back. Normally I'm planning on streaming probably like in the mornings on Mondays, but because it's New Year's Day, I might be a little bit delayed. It depends upon how much sleep I get. But I'll figure out and finalize the actual schedule itself, and I will post that onto Discord this weekend as soon as I have that. And if you want to join that so you can see the schedule when I put that on there, here is a link to Discord. And that's all I've got. Thank you everybody for hanging out, and I think we learned a lot. This is pretty awesome, and I'm looking forward to the next fun stuff. I will see you all next time. Bye.